Discramon is a card dueling game. To realize the card throwing, I needed a curved projectile which would be replicated in multiplayer. In this tutorial series, I'll show you my solution step by step and in several parts. Here I'm using Unreal Engine version 5.1 and the first person template for this tutorial. The first step is to open the first person character blueprint. In here we are going to make a line trace to determine the start and ending point of our throw. Press right click and type line trace by channel. Get your first person camera component and drag it onto the blueprint. Drag off the pin and search for the Get World Location node. Now right click and search Get Control Rotation. This node will return the rotation of the player controller. Drag off a pin and type Get Forward Vector to create a vector. We will multiply this vector by a float to determine how far our trace will go. Convert the pin to a float and type something like 5000. Now we will add together our world location from the camera with our newly created vector to get the endpoint of our trace. Connect this pin to the end and the world location to the start. We need the event to fire this line trace. In this example I use the left mouse button. Hook up the pins, and if you want to see the line trace in the editor, change Draw Debug type. For now we are done in here, so we can close this blueprint. So let's create two blueprints of type actor. The first one I'm going to call BP_projectile. The second one is called BP_trajectory. Open up your projectile and in the details set replication to true. Now add a static mesh that you want to use as your projectile. In this example I'm going to use a simple sphere. Save your blueprint, close it and open the BP trajectory. Also set this actor to be replicated. In here we are going to need a spline, so add a spline component and make it the default scene route. The first thing we are going to need in this blueprint are two variables. You change the type to vector and call it starting position. Make it instance editable and expose on spawn. Also set replication to replicated. Now we can duplicate this variable and call the second one end position. We are also going to need a timeline. Press right click, search for Add Timeline and give it a name. It's very important that this timeline is also replicated. Open it and press the Replicated button. Add a new float track. Call it something like distance. And for now set the length to 1 second. Create two new keys. The first one will be time 0 and value 0. The second one will be at time 1 and value 1. Close your timeline. Now we are going to need some custom events. Press right click, search for Add Custom Event. This event will be run on the server. So I call it SV_commit throw. I duplicate this event and the second one will be a multicast. So I call it MC_commit throw. Now we're going to set the replication settings accordingly. Set the first event to be run on server and reliable, and the second event to be a multicast, which is also going to be reliable. If you have problems with your multiplayer setup, sometimes it's worth to check if you actually set the replication settings according to the name of your event. Now we are going to get our spline and search for a set location at spline point node. We connect the pin from the multicast to this node. Duplicate it and set the second point index to 1. The first one we can leave at 0, and also change the coordinate space on both nodes to world. So basically what we're doing, as soon as this actor will be created, it will call commit throw on the server. The server will then call commit throw multicast, so all clients will execute the throw. We need to set this up correctly, so from the server commit throw, call the multicast commit throw. Also, we are now going to need our starting position, so get the variable and connect it to the first node. Get the ending position and connect it to the second set location at spline point node. We still need to hook up spline as target on the second node. Select the breakpoint and the spline, press Q to make it look pretty. This multicast event would be a great place to add some sound if we like that. To save some bandwidth, clients should play sound files themselves. So we are going to add a play sound at location node. And we can also use our starting position as the origin. Select the sound file you like and we can continue. Now we are going to create one more event. This will also be run on server. Add a custom event and call it sv_spawn projectile. Don't forget to set the replication accordingly and also make it reliable. So our server will spawn the projectile and also have authority over it. But the client will move the projectile by itself. If you want to make hit detection, you can make this on the server side, but more to it later. So now from here we are going to get the spawn actor from class node. We select our projectile as the actor to be spawned. Also, we are going to use our starting position variable as the location for our spawn. So split the struct pin and connect it up. Here I also changed the spawn scale. I've set 0.1 to make a smaller sphere. Depending on the static mesh tool you are using, the scaling will not be necessary. Okay, our multicast event will set the start and ending position of our spline. Now we can call the spawn projectile event on the server. One thing that's also useful is to promote our spawned projectile to a variable. So drag off the pin and press promote to variable. Call it something like projectile and set it to be replicated. We will need one final custom event. This will move the projectile along the spline and will only be executed locally. So there's no need to change the replication settings, just rename it properly. I will call this event right after we created our projectile. Hook up the custom event to the play from start node on the timeline. Now we're going to use our spline component, and from here we drag off a pin and search get spline length node. This is a common setup to move objects along a spline. Next, we are also going to need the get location at distance along spline node. From our spline length we will get a lerp node. This will linearly interpolate between the two values. Get the distance and use it as b, and get the return value and use it at the distance along spline node. We take our value from our timeline and use it as the alpha for the lerp. Now we can get our projectile variable and set the actor location. On update of the timeline, we will set our actor location accordingly. The distance along spline will be the location we will set it to. One thing we still have to do is set the coordinate space to world on this node. We may also want to destroy the trajectory blueprint once the projectile has reached its destination. Drag off the timeline finished and search the destroy actor node. For now, this blueprint should be ready. So finally, we will want to spawn our trajectory blueprint. We go back to our first person character blueprint and open it up. In here, after our line trace, we are going to set up a server event that will spawn a trajectory. So I create another custom event and I call this sv_initiate throw. Let's set this event to be run on server and reliable. Also, we are going to need two inputs. Create two variables and change the variable type to vector. These inputs will feed our start and ending position from our line trace to our trajectory blueprint. Now take the onHit pin from your line trace and break the hit result. We get the server event we just created. Our end position will be the result of our hit. Take the location pin and feed it into the end. Your setup may be different than mine and you don't want to use the camera as the start of the throw. You could use any other component, just remember that you could run into an issue where your projectile collides with the character mesh. You can resolve this by changing the collision settings inside the projectile. But in this example I use the camera world location as the starting position for our throw. From our server event initiate throw, we are going to get the spawn actor node, and in here we can finally spawn our blueprint trajectory. Now we connect our two input variables to the start and ending position. Also break the struct of the transform and set the starting position as the initial spawn transform. Now we're finished. You can compile and save your blueprint and we can test it in the editor. As you can see, we can shoot our balls and we also see the line trace. To test it in multiplayer, change the net mode to play as listen server and increase the number of players to 2. When you test the game, you can see that you see the projectile both on the server and on the client. And also run around. Oops. Depending on the type of game you're creating, you may want to set up different collision channels inside your projectile, so you can have different teams with different collision channels. But right now I'm done with the tutorial. Next time I'd like to curve the spline so we can have a curved trajectory and also do some other crazy stuff. See ya!